Today, we are joining you from Ngunnawal and Ngambri country, and I'd like to extend my respect to any First Nations people from around the world who may be joining us today. Our first speaker is Dr. Andrew Heap, the Chief of Minerals, Energy and Groundwater Division. He has 22 years of professional experience in leading geoscience research as a senior leader in Geoscience Australia, with a track record of successfully delivering energy and mineral, carbon capture and utilisation and storage, marine geoscience and groundwater programs. Andrew has responsibility for leading programs to build a national prospectus of Australia's mineral, energy and groundwater resources using geological information. Andrew graduated with first-class honours in geography from the University of Auckland, New Zealand in 1996 and completed his PhD in Earth Sciences at James Cook University in 2000. Over to you, Andrew.
Thanks for that kind introduction, Carol. Hello everyone. As Carol said, I'm Andrew Heap, and as the Chief of the Minerals, Energy and Groundwater Division at Geoscience Australia, it is my great pleasure to open the Exploring for the Future Program International Showcase for 2022. Before I talk about pre-competitive geoscience and the Exploring for the Future program specifically, I'd like to introduce a little about Geoscience Australia. We are Australia's national geoscience organisation, and our purpose is to be the trusted advisor on earth sciences to inform government, community and industry decision making. Our history dates back almost to Australia's federation, when it was decided by the newly formed federal government to establish the Australian Survey Office in 1910. We support evidence-based decisions through information, advice and services of Australia, delivering earth sciences for Australia's future. We have just over 600 employees and many more contractors, mostly working in Canberra, Australia's capital city. Our priorities are to build Australia's resources wealth, support Australia's community safety, secure Australia's water resources, manage Australia's marine jurisdiction, create a location-enabled Australia, enable an informed Australia, and ensure we are a high-performing organisation. Through our pre-competitive geoscience programs, such as Exploring for the Future, we're building Australia's resources wealth and securing the nation's water resources. The work we undertake on behalf of the government is referred to as pre-competitive geoscience because it is the early stage of information. It comes before private sector investment, not instead of it. Government investment in pre-competitive geoscience establishes fundamental information about the geography and geology of Australia that helps us to sustainably manage and harness the full potential of our natural resources. It acts as a prospectus, if you like, driving investment in resource exploration and creating jobs and growth opportunities, especially in regional Australia. It is also creating the pipeline of new projects required to support Australia's transition to net zero, grow our green economy, and help sustainably manage our environment. In my talk today, I'll focus on the value of pre-competitive geoscience to Australia. Beginning in 2016, the Exploring for the Future program is a $225 million investment over 8 years by the Australian government in pre-competitive geoscience. The program is building a comprehensive understanding of our national mineral, energy and groundwater resource potential. The following short video describes the program in a bit more detail.
Since 2016, the Exploring for the Future program has been transforming our understanding of Australia's geology. Using innovative tools and techniques to image, characterise and assess the subsurface, the program is supporting resource exploration, regional development and informed decision-making across Australia. Today, the Exploring for the Future program is building a world-leading national picture of Australia's mineral, energy and groundwater resource potential. The Australia's Resources Framework project is delivering a national view of Australia's surface and subsurface geology, extending fundamental national datasets and geological models and national mineral potential assessments and identifying economic fairways. The National Groundwater Systems Project is improving our understanding of Australia's groundwater resources to support responsible management and water security into the future. The Australia's Future Energy Resources Project is evaluating the potential for new energy commodities in Australia, including oil, natural gas and hydrogen, and technologies like carbon capture, utilisation and storage to support the nation's transition to a low-carbon economy. The Darling-Conamono Della Marian project is delivering new data and knowledge to support water management along the Upper Darling River and to assess base metal and critical mineral potential across a vast area of southeastern Australia. The Officer Musgrave project is delivering new insights into geological processes to support water security for remote communities in the Musgrave province and evaluate the energy potential of the Officer Basin. The Barkly-Isa Georgetown project builds on the first 4 years of the program, testing the undercover geology through stratigraphic drilling and delivering new data and knowledge to assess mineral and energy potential in undercover regions between Tennant Creek, Mount Isa and Georgetown. Our program support projects are improving the way we deliver and communicate our geoscience data and knowledge to our stakeholders. At its heart, the Exploring for the Future program is contributing to a sustainable, long-term future for Australia through an improved understanding of the nation's subsurface resources for the benefit of Australia.
This diagram shows how the program activities and outputs you've just heard about are leading to tangible outcomes and impacts for Australians. The technical talks that follow will each focus on a component of the left-hand side of the impact pathway, starting with an overview of the new data and tools we are advancing, the application of these to growing our understanding of Australia's geology, and the work we are doing to advance mineral systems knowledge, as well as the resource potential of hydrogen and green steel in Australia. My talk today will focus on the right-hand side of the diagram, highlighting the outcomes and impacts pre-competitive geoscience is having in meeting government priorities. While perhaps not immediately apparent, pre-competitive geoscience is delivering on each of the government priority areas shown on this slide. I'll share some case studies on these priorities demonstrating that the pre-competitive geoscience model works. World events are having a big impact on the cost of living in Australia, with food prices particularly affected. Australia's agricultural sector is a significant contributor to our economy and global food supply. Yet until very recently, we have been reliant on potash imports for use as fertiliser. Our reliance on imports has reduced and will continue to do so with the establishment of a new potash industry in Australia, propelled by a pre-competitive study undertaken by Geoscience Australia in 2012. The study was originally focused on studying the water, groundwater and soils of Australian salt lakes for their potential to supply lithium, a key mineral in batteries. However, unlike in Chile, it turned out Australian salt lakes don't contain lithium. But what they are rich in is potash, and not just any potash, but sustainably produced sulphate of potash, which is a premium form of fertiliser. We know this because our pre-competitive geoscience studies focus on assessing a broad range of resources. That's important because, as this case study shows, you don't always find what you're looking for. Our report, published in 2013, resulted in a major shift in exploration focus by industry to potash. And in the words of Karen Patterson, CEO of Trig Mining, Geoscience Australia's Salt Lakes report has underpinned the development of Lake Throstle, and in fact the entire potash industry now emerging in Western Australia. According to the Australian Securities Exchange, or ASX, the reported geotable potash resource across Australia is worth just shy of $100 billion. With commercial production commencing in 2021, the Australian potash industry has just come in time, given recent global events have caused potash prices to almost double. Without Australian government investment in pre-competitive geoscience back in 2012, we wouldn't be able to pivot and identify domestic sources of potash supply today and be on their way to self-sufficiency. Understanding Australia's mineral potential is important to support our transition to net zero emissions by 2050. Clean energy technologies require a wide range of minerals and metals, including critical minerals. Some forecasts predict up to a 5-fold increase in demand for metals like copper and nickel, which are key components of numerous low emissions technologies, as illustrated on the right-hand side of the slide. Australia has significant endowments of many of the metals, including critical minerals, essential for the production of these emerging technologies. As well as large critical mineral reserves, Australia has significant endowments of nickel, copper and bauxite. This represents a unique opportunity for Australia to be a trusted and reliable global supplier of these in-demand resources. Even with known strong demand for critical minerals, pre-competitive geoscience is needed to stimulate private sector exploration investment to locate these new mineral deposits and generate that pipeline of projects needed to maximise the benefit to our nation. For example, in 2014, Geoscience Australia undertook the first ever national multi-criteria mineral potential assessment of nickel, copper, platinum group element deposits, a globally significant but underrepresented style of mineralisation in Australia. Guided by previous studies published in the international literature into how such deposits form, we generated predictive maps derived from all the available data and combined them to make a heat map of mineral potential. The report and prospectivity map on the left revealed several high potential areas shown in red, including about 70 kilometres northeast of the city of Perth, the capital of Western Australia. When we first presented this work publicly, there was scepticism from many that an undiscovered deposit could be so close to the city of Perth given the 1970s nickel boom in the region. 2 years later, these outputs, along with pre-competitive datasets and legacy exploration information held by the Geological Survey of Western Australia, was a catalyst for Chalice Mining, a junior explorer at the time, to pick up ground in the area. Fast forward to 2020, and the first drill hole at Chalice Julimar project became the discovery hole for the world's largest palladium, platinum, nickel, copper, cobalt and gold discovery in the last 20 years, propelling Chalice to an ASX 200 company. Making a mineral potential map is a far cry from a discovery, so we congratulate Chalice on their success. Nevertheless, this story speaks to the value of pre-competitive geoscience in attracting exploration, narrowing the search space for explorers, and accelerating the discoveries needed to support our transition to net zero emissions by 2050. Based on the assumption that the Gonaville deposit at Julimar becomes a mine, every dollar invested by government has been estimated by ACL Allen Consulting to generate at least $1,000 and as much as $1,500 of additional benefits to the economy. That's a pretty good return on investment in my book. In addition to the value of the deposit, the success of Chalice's Julimar project has sparked an exploration rush to the region by other companies. The final report from ACL Allen Consulting, which is based on the latest resource numbers recently published by Chalice, has been released online today and can be accessed via the reference at the bottom of the slide. Investment in pre-competitive geoscience also gives us options for securing our future energy supplies. As part of the Exploring for the Future program, we've been studying the hydrocarbon potential of the South Nicholson Basin, which spans the Northern Territory and Queensland borders. This is a reflection seismic profile, most of which was acquired across the basin in 2017. Like an ultrasound to image the inside of your body, the seismic profile shows the different rock layers inside the Earth down to about 15 kilometres below the surface. The prominent saucer-shaped depression in the middle of the profile is the previously unknown Carrara Subbasin. It's remarkable that in the 21st century, we are still discovering major geological features in Australia we didn't know existed. It highlights how much more there is left to learn about our continent and the Earth beneath our feet. The discovery of the Carrara Subbasin triggered a major energy company to invest in exploration tenements and to explore across the basin. A junior exploration company also recognised that the rocks that host the Century zinc mine in Queensland, a world-class deposit, continued westward, coming to within exploration depth on the other side of the Carrara Subbasin in the Northern Territory. This led them to invest in mineral exploration tenements along the basin's western margin, a move highlighting the value of considering how geology crosses state and territory boundaries and the value Geoscience Australia plays as a national geoscience organisation. This was an excellent outcome, since the purpose of the seismic profile was to assess the energy and mineral potential of the region. But to do this rigorously, we needed samples of the basin rocks. Partnering with the Mineral Exploration Cooperative Research Centre, or MINEX-CRC, we drilled the National Drilling Initiative Carrara 1 stratigraphic well through the sub-basin in 2021. The well hid vucks of oil and other hydrocarbon indicators in the basin, demonstrating that there was an active petroleum system in the region. Dating the rocks also confirmed rocks in the Northern Territory are the same age as those that host the Century zinc mine in Queensland. Confirmation of this relationship sparked interest from a global major minerals explorer, who entered into a joint venture with the junior company providing vital capital for an ambitious exploration program. To manage our precious water resources, basin-wide water management plans need to have reliable information on groundwater and surface water interactions. 2 years ago, we completed a project focused on the Upper Burdekin River catchment in North Queensland, which supports pastoralists and farmers, groundwater-dependent ecosystems, natural springs and the water supply for the regional town of Charters Towers. Our study was focused on the headwater region, which includes 40-million-year-old lava fields with volcanic centres, as shown on the left-hand side of the slide using the high-resolution digital elevation model. Combining Queensland stream monitoring data with new hydrochemistry data collected in our study, the team identified that the highly heterogeneous lava field supplies 60 to 90% of the water flow to the Burdekin River in dry periods, with recharge of the lava fields controlled by intermittent major recharge events. This example highlights how interlinked the groundwater and surface water systems in the region are, and how important it is to manage them as a connected system. Queensland water authorities are now using this information to develop a sustainable water management plan for the region. So far, I've shared examples focused on how specific new pre-competitive data and knowledge have informed decision making. Now, I want to share with you an example of how we're working to transfer that geoscience data and knowledge into applications all decision makers can use. In this case, the economics of hydrogen production. Hydrogen production is influenced by many different factors, shown in the left-hand image, all of which can change spatially across Australia. For example, solar and wind capacity is not equal everywhere, and carbon dioxide cannot be stored everywhere. Working with Monash University, we have developed an online tool that calculates net present day value for a potential hydrogen project given a set of initial assumptions which the user can vary. The map shows an example of a model output, with darker red areas indicating higher economic potential for hydrogen production. The tool is informing development and implementation of our hydrogen policy and helping the private sector to assess exploration and investment opportunities across Australia. The result is strongly influenced by the current distribution of infrastructure, such as the railway line across a nullable plain. Using our open source code, users can assess how the resource potential changes with new infrastructure, a particularly useful feature in assessing potential development of marginally economic minerals projects. This capability can be adapted to supporting future infrastructure planning more broadly across Australia. Now, I want to turn our attention to the economy and mining sector more broadly. The mining sector is the backbone of the Australian economy. It accounts for over 10% of GDP, employs over 250,000 people, and is forecast to account for over $419 billion in annual export value in 2022-23. But we cannot take this success for granted. Our world-leading mining sector requires ongoing exploration success to provide a pipeline of resource projects to develop. The graph on the right shows that Australia's share of global exploration expenditure fell from a high of 23% in 1993 to a low of just 8% in 2015. The long-term exodus of investment from Australia was largely driven by the view that Australia was a mature exploration destination, where all the rocks that could host a mineral deposit had already been explored, with nothing left to find. We, alongside others in government, academia and industry, didn't share that view. Since 2012, we have been part of the Uncover initiative, focused on articulating the opportunities for exploration undercover and the need for pre-competitive geoscience to unlock this exploration frontier. It's hardly a lucky coincidence that the rise of Australia's share of global mineral exploration since 2016 aligns with the start of the Exploring for the Future program, which has already revealed new resource potential in undercover regions. It's clear perceptions and practice by industry have changed. So where is all this exploration activity? This map shows new and reinvigorated resource exploration tenements granted to industry since 2016 that were stimulated by Geoscience Australia's pre-competitive geoscience. New activities are occurring over 276,000 square kilometres based on our work. That's an area larger than the landmass of New Zealand. Many of these are targeting critical minerals, shown in green. There is a concentration of tenements in the Central Eastern Northern Territory and Northwest Queensland, which, as I've shown, was a focus of our work in the Exploring for the Future program between 2016 and now. The concentration of tenements in southwestern WA was sparked by the nickel, copper, platinum group elements potential map and the Julimar project discovery I mentioned earlier. I've told you how wonderful the program in pre-competitive geoscience is, but there's nothing quite like hearing it from those stakeholders who use our data and information.
Encounter has a long history of project generation and exploration. As a result of the Exploring for the Future program, Encounter now has a large presence in the Northern Territory. The Exploring for the Future hydrogeochemistry data was instrumental in the securement of the Elliott project. BHP has now partnered with us at the Elliott project through a $25 million earn-in and joint venture agreement. Our foundational dataset that was of most use was the South Nicholson and Barclay seismic Exploring for the Future data. Just last month we announced that we have entered into 2 new farm-in agreements with South 32 at our Jessica and Carrara projects in the East Tennant and South Nicholson regions. The understanding of a new geological province undercover in the Northern Territory is no small task. As a result of this extensive pre-competitive data, the Territory is now at the forefront of copper exploration in Australia.
Barclay Hardware JV Proprietary Limited, as it's known, is half owned by Delilah Curry Council Aboriginal Corporation and by Centre Corp, which is another organisation that are based in Alice Springs but invest through the Northern Territory. We've found that we've had probably in total 5 or 6 mining companies have come to Tennant Creek to do various sort of work or exploration. I would say 4 of those have taken up and set up accounts with us, with the hardware business. You know, that's extra business for us, so we've been happy with that. Plus, the other ones that haven't set up accounts have still been coming into the hardware store anyway and to purchase items and things like that.
The Department of Planning and Environment have taken the opportunity to co-invest in Geoscience Australia's Upper Darling Floodplain Survey program. We could see the program had potential to help us improve our understanding of groundwater and its complex interactions with the Darling River in the area. Additional data will be collected around the Upper Darling Salt Interception Scheme, which helps keep salt out of the Darling River. The survey is almost complete and we look forward to the insights we can gain from the data.
Bridgeport really welcomed the opportunity to assist Geoscience Australia in its initiative to investigate the enhanced oil recovery potential of the residual oil zones of Australia's discovered oil fields. The study is a first for any Australian government and an overdue first for the oil and gas industry of Australia. The project will complement Bridgeport's plans to recover additional green Mooney oil reserves by injecting large volumes of CO2 that would otherwise be vented to the atmosphere and adding to Australia's greenhouse gas emissions.
Activity is one thing, but just how successful has this resurgence in Australian exploration been? Over the last 5 years, there have been 20 Tier 1 and Tier 2 mineral deposits discovered around the world. An example of a Tier 1 deposit is Olympic Dam in South Australia or Broken Hill in New South Wales, whereas the Tier 2 deposit is akin to many of the gold deposits in the eastern goldfields around Kalgoorlie in Western Australia. A total of 35% of those deposits were discovered in Australia. This includes 2 of the 4 Tier 1 deposits, Julimar and Hemi, both of which are underpinned by pre-competitive geoscience. Overall, 2/3 of Australian discoveries were underpinned by pre-competitive geoscience. Given Australia's share of global exploration expenditure, it's clear we are outperforming the rest of the world, and pre-competitive geoscience and programs like Exploring for the Future are key contributors to that success. This success does not come from working in isolation. It is the result of the close-knit geoscience community across Australia. We greatly value our collaborations across the Australian, state and territory governments, cooperative research centres, national collaborative research infrastructure strategy partners and academia. Thank you, and I look forward to continuing our collaborations. I trust that I have convinced you that pre-competitive geoscience has proven its worth and is bringing about a step change in our understanding of Australia's mineral, energy and groundwater resources. Specifically, I see the journey we are on as leading us towards integrated, holistic, multi-scale and multi-resource assessments to inform decision-making by government, community and industry. In that vein, I'm very pleased to formally release another 13 extended scientific abstracts to add to the 63 released from the program in 2020. These provide excellent short format summaries of the many scientific aspects of the Exploring for the Future program, and I encourage you to peruse them all. If you want to know more information about the program, I encourage you to browse our revamped website and explore the data discovery portal, which includes decision support tools like the Hydrogen Economic Fairways example I showed in my talk earlier. Thank you for your attention today. I now hand you back to Carol for the remainder of our showcase.